When simplifying algebraic expressions, often we have to use the distributive property, which is algebraically represented like this. A times B plus C is equal to AB plus AC. In other words, when you multiply a bracket with something, everything inside that bracket, every term that's connected by plus or minus symbols, that's going to end up multiplied by what you multiply the whole bracket with. So A is multiplied by B, and A is multiplied by C. So here, let's use the distributive property to rewrite each expression. 3 times A plus 5, well, that's 3 times A. And then 3 times plus 5, so plus 15. Negative 2 times D minus 3, well, that's negative 2 times D. And then negative 2 times negative 3, which ends up being positive 6. Remember, guys, subtracting something is just adding the negative, really. When you have a plus sign separating the parts of an algebraic expression, the parts are called terms. In terms that contain a variable, the numerical part of the term is multiplied by the variable parts, all of them, to whatever powers are relevant. Like, say, 3xy squared. This is 3 times x times y times y. Now, you call this 3 the coefficient. The constant term is, we don't generally consider the constant term in an algebraic expression, like say plus 7. We don't generally consider this to be a coefficient, but we call it the constant term. The numerical part of terms that have variables is called the coefficient of the variable. And if there's no variables, in other words, all the variables are to the 0th power, i.e. are not multiplied in, that's a constant term. Like terms contain the same variables, such as 3x and 2x, or 3xy squared and 5xy squared. Identify the terms, like terms, coefficients, and constants in this expression here. 7x minus 5 plus x minus 3x. Now, all terms are added together. They might be connected by subtraction symbols, but that's just adding the additive inverse. So the negative is included in what you're adding in. So terms, 7x minus 5, x, and negative 3x. Like terms are 7x, x, and negative 3x. Coefficients 7, 1, and negative 3 from each of the terms that actually has variables present. Constants, well, negative 5 is the constant term here. Okay, if it has no like terms and no brackets or parentheses, then an algebraic expression is in simplest form. So in other words, you've multiplied everything out as much as you could, you've added the things together as much as you could. Now let's say we need to simplify this expression. Well, what's the first thing we do? The first thing we do is we group like terms. So negative 2m and 6m, positive 6m, are like terms. Plus 5 and minus 3 are like terms. Okay, then you group the like terms, and then you add them together. Negative 2m plus 6m is 4m, and plus 5 minus 3 is plus 2. Okay, then, let's use the distributive property to rewrite each expression here. So let's do some exercises. 2 times c plus 6, well, that's 2 times c plus 2 times 6, which is 12. Negative 4 times w plus 6, that's negative 4w. And then negative 4 times positive 6 gives us minus 24. Now b minus 4 times negative 3, well, that's negative 3 times b, so negative 3b. And negative 4 times negative 3, or vice versa, that comes out to plus 12, because the negative signs cancel out. Identify the terms, like terms, coefficients, and constants in the expression here. I, for one, like to go for terms and then coefficients and constants, because those, you can actually make it a table. Coefficients and constants. You can make it a table by going terms. 4m, negative 2, 3m, and 5. So, the coefficients are 4 and 3, whereas the constants would be negative 2 and 5. The like terms, if you have multiple constant terms, they are like terms, because they have the same variables to the same exponents. In other words, none of them, or to the exponent, all of them to the exponent of 0. Like terms are 4m and 3m, or negative 2 and positive 5. Okay, then, let's simplify these expressions. 3d plus 6d. Well, if there are 3d's and 6d's, there's a total of how many d's? There's a total of 9d. 2 plus 5s minus 4. The like terms here are 2 and negative 4. So we leave 5s over here, and then we add 2 and subtract 4. That means a total of negative 2. 2z plus 9z. If you are not comfortable with going straight to the conclusion, it's fine to spend a step writing out the like terms grouped together, okay? Like you can go 2z plus 9z plus 3 minus 8. There's nothing wrong with this at this level, at least, like at this grade level. It's okay. Just make sure you get it right. That's the important part. So it's 11z plus 3 minus 8. That's minus 5 overall. So as long as you make sure you get your calculations right and you get your answers right, it's fine to take a step that could be abbreviated away. Solving two-step equations. A two-step equation contains two operations. To solve a two-step equation, undo each operation in reverse order. Okay, what's the last thing that was done when you go negative 2a plus 6 and then you equals something? What's the last thing you do? Oh, we know that order of operations is brackets, exponents, division multiplication, or multiplication division, just in order, and then addition subtraction. So the last thing you did was a plus 6. That means to undo that, you subtract 6 from both sides, and you end up with negative 2a equals 14 minus 6, if you like. If you can think of it as moving it over and changing the sign. That's 8. So that's negative 2a. And now you divide. A is equal to 8 over negative 2. I mean, technically this is dividing both sides by negative 2, but, well, you might as well think of it as moving it over. So that's going to end up being negative 4. Check your solution. Substitute back into left side. Left side equals negative 2 times negative 4 plus 6 equals 8 plus 6 equals 14 equals right side. QED. Although usually it's left side equals right side, QED. Okay. Sometimes it is necessary to combine like terms before solving an equation. Suppose you have this. How do you solve it? Well, you can move the negative 7 over to isolate all the x terms. So all the terms with the variable x. You end up with 5 plus 7 is equal to 6x minus 2x equals 4x. So 4x is equal to 12. X is equal to 3. Check your solution. Well, right side is equal to 6 times 3 minus 2 times 3 minus 7. So 18 minus 6 minus 7. So that's 5. Which is equal to the left side. Therefore, quadrat demonstrandum. What's been asked has been shown. Of course, if you had to substitute into both the left and right sides, you would do them separately, and then at the end you'd be like, oh, left side equals right side, QED. Let's solve each of these. Check your solution. We'll do that part by talking, because I'm pretty sure y'all don't particularly enjoy watching me write on the board. 2d plus 5 equals 9. 2d is equal to 9 minus 5, which is 4. d is equal to 4 over 2, which is 2. Yeah. So you're kind of expected to reduce the number of steps down to this many, eventually, for two-step equations. So 6 equals 3z plus 5. Well, 3z is equal to 1. Or 6 minus 5 equals 1. So z is equal to 1/3. Now, when it comes to checking our solutions here, what we do is sub back in, and we go left side equals 2 times 2 plus 5 equals 9 equals right side, QED. Here, it's going to be right side equals 3 times 1/3 plus 5 equals 1 plus 5 equals 6 equals left side, QED. 2s minus 4 equals 9. Well, 2s is equal to 9 plus 4, which is 13. And s is going to be equal to 13 over 2. If we want to write out the check, it's 2 times the value we found for S for left side, minus 4, which is equal to 13 minus 4, which is equal to 9, equals to right side. Therefore, QED, what's been asked has been shown. So, how about this equation here? 2 plus y over 4 equals 5. Well, y over 4 is therefore equal to 5 minus 2, which is 3. So y is equal to 3 times 4, which is 12. Now, when we check our solution, we sub it back in and we go left side equals 2 plus 12 over 4 equals 2 plus 3 equals 5 equals right side QED. Negative 1/3 Q minus 5 equals negative 3. Well, that's negative 1/3 Q is equal to negative 3 plus 5, which is 2. Now, Q is just, you can say divide by negative 1/3, but we all kind of know that just means multiply by negative 3, so negative 6. Because 2 times negative 3 equals negative 6. Okay, then. How do we check? We sub back in and we go left side equals negative 1/3 times negative 6 minus 5, which is equal to 2 minus 5, which is equal to negative 3. Oh, that's equal to the right side. Great, QED. 4 minus g over 6 equals 0. Well, by all means, you can divide by negative 1/6 if you like, but I prefer this approach. So keeping things positive is usually less prone to error for a lot of people for various reasons. So g over 6 is equal to 4. Okay then, cross multiply and you end up with g is equal to 4 times 6 is 24. Now when you substitute back in, you get left side equals 4 minus 24 over 6. So 4 minus 4 is equal to 0 equals right side. Okay, QED. Some verbal sentences can be translated into two-step equations. For example, translate each of these sentences into an equation. Twice the number of Volkswagen cars in the parking lot plus 5 equals 13. So, let there be V Volkswagens. Okay. Seems like a reasonable letter to choose, in my opinion. So, you find 2V plus 5 equals 13. Twice the number of Volkswagens plus 5 equals 13. Now, the 5 stores present in this food court in the museum represent half of the museum's total number of stores plus 1. So, let the museum have S stores. To be fair, if it has a central food court somewhere, and then it say has a couple other stores scattered about for convenience or as gift shops, yeah, that's perfectly reasonable. So 5 stores is equal to half the museum's total, so 1/2 of S, plus 1. Oh, hey, that means the museum has 8 stores in it in total. That means there are 5 in the food court, and then you have 3 scattered about somewhere. That actually seems pretty reasonable. I mean, you have a museum gift shop probably, and then you might have 2 other random convenience stores around. If this is a big enough museum, that is. After a sentence has been translated into a 2-step equation, you can solve the equation. Translate the sentence into an equation, then find the number. 13 more than 5 times the number is 28. Let the number be n. Okay, so 13 more than 5 times. 13 is being added to the 5 times. So this is 13 more than 5 times a number. 13 more than. That means 13, the additional 13 is being referenced to 5 times a number. And that gives you 28. Okay, then you subtract 13 from both sides, or you can think of it as moving over and changing sign. And you get 28 minus 13 equals 15. And then n equals 15 over 5. Or you could have just written n equals 3 by this point. So the number is 3. Translate each sentence into an equation and then find each number. 5 more than twice a number is 7. So let each number be n. There. 5 more than twice a number? Well, that's 2n plus 5 equals 7. 2n equals 7 minus 5 equals 2. N is equal to 2 divided by 2, or 1. 11 more than 3 times the number is 2. Okay, then, so 3 times the number plus 11 is equal to 2. 3n is equal to 2 minus 11, or negative 9, and n is equal to negative 9 divided by 3, which leaves us with negative 3. 7 less than 9 times the number is 5. Okay, so 7 less than. That means it's this thing after that, minus 7. It's 9 times the number, minus 7, is equal to 5. 9 times the number is equal to 5 plus 7, or you can think of it as plus 7 on both sides, equals 12. N is equal to 12 over 9, or 4 over 3, or 1 1/3. Although for some reason it's not that popular to go simplify a improper fraction and convert it into a mixed fraction all in one step, presumably because it's pretty easy to get something wrong, which is not fun. Okay, 2 more than 4 times the number is negative 7. So 4n plus 2 equals negative 7. So 4n equals negative 7 and then minus 2. So negative 9. N is equal to negative 9 over 4. So negative 2 1/4. 8 less than 3 times a number is negative 14. Well, you have 3 times the number, and then it's 8 less than that, so minus 8 equals negative 14. That means we're looking at 3n is equal to negative 14 plus 8. You can think of it as adding 8 on both sides if you prefer. So, negative 14 plus 8 is negative 6. You can write it out if you need to, just saying. Like, extra lines is not a problem. Getting it wrong, on the other hand, is a problem. So, negative 6 divided by 3 gives you negative 2. Okay, then. If you have variables on both sides, you have to isolate each given variable to solve the equation. Why did I say each given variable? Well, what happens if you have, say, 2x plus 3 is equal to 3y minus 5? Well, first you isolate the 2x, you move the negative 3 over, and then you find x is equal to some function of y. So you express x in terms of y and the constant. And you can also express y in terms of x and the constant. However, at present, we're only dealing with having the same variable on both sides, which means we still have to isolate the variables. So here, we're going to end up with negative 9, and then if we subtract the 3x over, we get 3x. So we're going to end up with a negative anyway. The answer for x is going to be negative anyway. So what do we prefer then? Do we have a negative 3x equals 9 and then divide across? No. Generally, you try to keep your divisions as having positive divisors, if possible. So that means negative 9 is equal to 6x minus 3x equals 3x. X is equal to negative 9 divided by 3. That's negative 3. And to check our solution, left side is equal to 3 times negative 3 minus 9. So equals negative 9 minus 9 equals negative 18. And right side is equal to 6 times negative 3 equals negative 18. Yeah, it's very common to see left side and right side being done side by side. Because, well, they are kind of left side and right side of the equation. So yeah, it's pretty normal for them to be side by side. And then you get left side equals right side and QED. In other words, we showed it. Yep, so we checked our solution and it was correct. Now solve 4a minus 7 is equal to 5 minus 2a. Well, you isolate the a's and you move everything else to the other side. That means you end up with 4a plus 2a, because you add 2a to both sides. And it cancels on this side. And you get 5 plus 7. You can think of it as moving it over and changing signs or adding 7 to both sides. It doesn't matter. Same result either way. So 6a is equal to 12. A is equal to 2. And to check, we get left side equals 4 times 2 minus 7 is equal to 8 minus 7. And right side, so that's 1. Right side, well, 5 minus 2 times 2 is 1. 2 times 2, so 5 minus 4 equals 1. Thus, we have left side equals right side, QED. What's been asked has been shown. Alright, let's solve each of these and check our solutions. We'll do the checking verbally for the most part, with maybe a couple where I'll show you guys the whole thing. So 6s minus 10 equals 2s. Well, you get 6s minus 2s, so you move that over. And you move the negative 10 to the other side and it becomes positive 10. So 4s is equal to 10. S is equal to 2.5, or 2.5. To check our solution, we substitute back in. Left side is equal to 6 times 2.5, in other words 15, minus 10, so that equals 5. The right side equals 2 times 2.5 equals 5. Therefore, left side equals right side, QED. 8r is equal to 4r minus 11. Well, that's going to give us 8r minus 4r is equal to negative 11. So 4r is equal to negative 11. R is equal to negative 11 over 4. Right. When we substitute back in, we would get left side is equal to 8 times negative 11 over 4. We do a little bit of canceling and we get negative 22 because it's equivalent to 2 times negative 11. 4r minus 11 on the right side, we multiply this in and we get negative 11 minus 11, so negative 22. Left side equals right side, QED. 25 minus 3u is equal to 2u. Well, that's 25 equals 2u plus 3u. Yeah, I might as well just show it all. So 5u is equal to 25. U is going to be equal to 25 over 5, which is 5. Okay, so when we sub in, we had left side equals 25 minus 3 times 5 equals 25 minus 15 equals 10. Right side is equal to 2 times 5, which is equal to 10. Left side equals right side. Therefore, quod erat demonstrandum. What's been asked has been shown. Okay then, let's do a few more. 8 minus 3z equals negative 8z, or z. So 8 equals negative 8z plus 3z. It's fine to take extra steps if needed. So negative 5z is equal to 8. Z is therefore equal to negative 8 over 5. So negative 1 3/5. 10x plus 9 equals 5x minus 3. Well, 10x minus 5x, you're going to end up with 5x when you isolate that. And on this side, negative 3 minus 9, that's going to be negative 12. Yeah, if you had more terms on both sides, I would tell you definitely show your rearrangement step. Just because you don't want to lose track of anything, or even risk losing track of anything. Show your rearrangement step, like show where you grouped like terms, and then simplify that, and then go on. X is equal to negative 12 over 5, or negative 2 2/5. Okay then, let's say we substitute in for this one. Let's show it. Left side is equal to 10 times negative 12 over 5 plus 9. In this case, we won't be able to write the right side here. Not enough space. So, that's going to be, well, you can cancel this. This becomes 2. So 2 times negative 12, negative 24. plus 9 gives us negative 15. Now, right side is 5x, 5 times negative 12 over 5, minus 3. These cancel out. So you get negative 12 minus 3 equals negative 15. So you have left side equals right side, QED. Left side equals right side, QED. Okay, how about this last one for this section? 16 minus 7d equals negative 2d plus 2. Well, you have negative 7d plus 2d. It's really recommended to write your rearrangement step if you have a lot of negative symbols flying about, just saying. And 2 minus 16. So you get negative 5d equals negative 14. d equals 14 over 5, which is equal to 2 4/5. Okay. That would not have been much fun to check. But hey, still perfectly doable. I mean, just substitute in. And you will find what happens. Well, 5d on the over here will get rid of 14 out of the 16. So you end up with 14 plus 2d in this bracket that used to be 7d. Which means you get 16 minus 14 minus 2d equals negative 2d plus 2. So in other words, 2 minus 2d equals negative 2d plus 2. Whoa, is anyone surprised? No. So that's one way you can check your answers without going through all the irritating fractions. Like you can use the parts that are easy to solve with mental math, and you can check your answers and be like, okay, this is correct. There's a saying called beating a dead horse. There's also a saying about dead horses in Chinese that translates to pretend it's alive and try to treat it. So basically, if you have no idea what you're doing, don't freeze up. Don't lock up in fear and like be incapable of doing anything. Act. Do something. So when you have no idea how to do a problem, you can use the guess and check strategy. This is good for helping you choose a strategy that's actually going to work. Realistically speaking, however, I expect this to be very rarely used outside of really tough math contest problems. So, the School Booster Club spent $776 on ski passes for the school ski trip. Adult tickets cost $25 each and student tickets cost $18 each. They bought 4 times as many student tickets as adult tickets. Find the number of adult and student tickets purchased. Okay. So let's say we don't actually know how to solve this. Well, let's guess at something useful. Okay, well, it would be useful to know the price of one adult plus 4 students. Is equal to 1 times $25 plus 4 times $18. So 4 times $18 is 72 plus 25. So $97 for a set. Okay then. $776 is how many sets? $776 is how many of these $97 sets? $97 is $100 minus $3. Okay, $776 is $800 minus $24. So 100 minus 3 times how many is 800 minus 24? Oh, it's 8 sets. Okay then, that means that there's 8 times 1 equals 8 adult. And 8 times 4 equals 32 student tickets purchased. Yeah. A lot of the questions where you are supposed to use a guess and check strategy at our grade and competence level, we are generally only guess and checking by going like, will this work? Oh, hey, it worked. Yeah, it's actually really hard to guess and check when you actually have an idea of how to do a problem, because to guess and check, you'd have to be like, in this case, oh, you're making necklaces, bracelets, and crystals. Yeah, it's this terrible. Like, you'd literally guess. Like, actually guess. You have 270 crystals, and you need 20 more necklaces. Each necklace has 8 crystals on it, so that's 160 crystals already taken up. The remainder is how many crystals? You have 110 crystals left. 8 crystals on each necklace and 3 crystals on each bracelet. That's a total of 11 crystals per pair. Oh, you got 10 pairs. Yeah, this is easy to do algebraically. Guess and check is actually harder for this problem. But, like, this is what you'd be expected to do for guess and check. 29 necklaces, 9 bracelets, and then you multiply and add together to get the number of crystals. 30 and 10, and you get 240 plus 30 equals 270. Yeah, okay. No surprise there. And 29 and 9, you would have gotten 11 less, which was 259. And you'd be like, oh, circle this row, it's correct. That's what guess and check would have you do, which is like, no, we're going to amend the problem, if need be. Because guess and check is when you basically didn't pay attention earlier, or if it's an unreasonably hard question for your grade level. So, 8 crystals on each necklace. Okay, let there be, because it says 20 more necklaces and bracelets, let there be bracelets. Okay? What we're being told is that 8 crystals multiplied by B plus 20, the number of necklaces, plus 3 crystals multiplied by B, the number of bracelets, is equal to 270. Yeah. 8B plus 160 plus 3B is equal to 270. So 11B is equal to 110, B is equal to 10, and 10 bracelets and 30 necklaces. Can be made. Yeah. Guess and check. Well, I mean, we worked out roughly where we're going to be looking at. Roughly. And that saved us a lot of work because bracelets we could have started at like 7 or something. 7, 8, 9, 10, 11 necklaces plus 20 for each of them. And then crystals, we would have had to work them out, probably with a calculator, considering you guys don't do that much mental math in your curriculum. So yeah, the guess and check method is only to be used when you have no clue what you're doing and you've done all the other questions that you know you could do already. So in other words, don't waste time on guess and check if there's other questions you could do that you actually have a vague clue what you're doing on. The 9th grade class is filling gift bags for participants in a school fundraiser. They put 2 raffle tickets in each child's bag and 4 raffle tickets in each adult's bag. They made twice as many adult bags as child bags. If they had 500 raffle tickets, how many child bags and adult bags did they make? You know what my idea of guess and check is? I'm guessing that I can solve this using algebra. Yeah, how many child bags and adult bags? Okay, let's start with child bags. Let's see child bags have been made. Okay, 2 raffle tickets for each child bags. 2 raffle tickets for each child bag. Plus 4 raffle tickets for each adult bag. How many adult bags were there? There were twice as many adult bags as child bags, so 2C is equal to 500. 2C plus 8C is equal to 500. Plus 10C is equal to 500. C is equal to 50. And 50 child bags. 100 adult bags, because twice as many adult bags as child bags. Adult bags. Don't buy raffle tickets, kids. It's a gamble. And gambling is not healthy. Yeah, you might have heard about the EU's whole thing about online gambling and video game loot boxes being a form of online gambling if purchased with real currency. It's hilarious. Yeah, I know. Inequalities. You've probably done greater than and less than relationships from back in like grade 2 or 3 or ish, from what I remember. They might have made the curriculum worse though since my time. So if you have a mathematical sentence that contains less than or greater than signs, you have an inequality. When used to compare a variable and a number, inequalities describe a range of values. Some inequalities use the symbols greater than or equal to and less than or equal to. Write an inequality for each sentence. Shipping is free on orders of more than $90. Well, the price, let price be P. P is greater than 90. The restaurant seats a maximum of 144 guests. Okay, let the restaurant's capacity be G, maybe? But wait a second. We've seen plenty of examples where we write expressions where we don't actually state what the variable is. That's you sometimes see that in your textbook, but that's not what it's supposed to be. It's supposed to be, let there be G guests seated. Because hey guys, there's such a thing as takeout and delivery too. So it's not guests served, it's guests seated. G is less than or equal to 144 because it can be equal to 144, i.e. the restaurant is fully seated. But you can't seat any more people than that. You can graph inequalities on a number line. An open or closed circle is used to show where the solutions start. You use open circles for strictly greater than or less than, and you use closed circles if the value where it starts is included, i.e. less than or equal to, or greater than or equal to. Now you can have an arrow pointing either left or right, and this arrow may be offset depending on the convention you use. For example, let's say we have D is less than or equal to -1. Well, depending on the convention you use, you might be looking at this. See? This is the convention from when I learned it. Well, where I learned it. This will allow you to compare multiple inequalities. Like say you got another one that's strictly greater than -3, you can see the overlap area and say, oh, this area fulfills both requirements. Whereas if you just drew the line along the number line as an arrow, you would have a much harder time portraying that relationship where you have two inequalities that overlap and you need to communicate how they overlap. D is greater than -1. Well, it's strictly greater, so we're going to be looking at an opens bubble. Now, it's a good idea to actually label these things, okay? Why? Because drawings are inherently imprecise. It's like, I know that this could be 1.9 or it could be 2. Well, which is it? Please be detailed. Please be specific. Exercises. Write an inequality for each sentence and then graph it. Our delivery time is guaranteed to be 29 minutes or less. Well, 29 minutes or less, that includes 29. So you end up having a full circle at 29. So labeling this, you have t is less than or equal to 29 minutes. Your speed must be at least 45 miles per hour on the highway. This, by the way, this drawing in and then doing this, is an artifact of my equipment not being good at scribbling a dot in one position. So, your speed must be at least 45 miles per hour. That means v is greater than or equal to 45. Now, it's good to have units on your number line if indeed they are required, which in these cases they are. Graph each inequality on a number line. A is strictly greater than -2. Well, open circle at -2, then you have A is greater than -2, label it. X is less than or equal to 3. Well, try a nice filled in circle on 3. So X is less than or equal to 3. And actually, depending on convention, you may not have to label the end of your inequality with an arrow, but in North America, you generally do. Just like with equations, you can do the same addition or subtraction from either side, from both sides, of an inequality, and the relationship still remains the same. For example, if you have r plus 5 is greater than 8, what happens if you remove 5 from both sides? Well, r is going to be greater than 8 minus 5. So r is greater than 3. Or rather, 3 is less than r. Like this is the same as r is greater than 3. Then graph the solution on a number line. Okay then. R is greater than 3. Okay? Now, x minus 4 is greater than or equal to -3. We can add 4 to both sides. -3 plus 4 is 1. Think about it. A value that's equal to or bigger than 1, when you subtract 4, is going to be equal to or bigger than -3. Like if you subtract 4, yeah. So x is greater than or equal to 1. Equal to 1. Okay. Solve each inequality and check your solution. So t minus 2 is greater than 1. T is greater than 1 plus 2, which is 3. what happens to the left side? Left side is equal to t minus 2, okay. And we know that t is bigger than 3. So if t is greater than 3, if t is bigger than 3, then what's left side bigger than? Left side is bigger than 3 minus 2. Which means left side is bigger than 1. Left side is bigger than right side. QED, because the right side is 1. So you might have to state right side equals 1. I can put a comma here. And then left side equals right side, QED. Okay, so b plus 9 is less than or equal to 8. If we subtract 9 from both sides, the same relationship still holds. So b is less than or equal to 8 minus 9, which is negative 1. So a value that's less than or equal to negative 1 plus 9 is going to give you a value that's less than or equal to 8. Oh, hey, it works. It fits what we were looking for. Yeah, so I'm just going to keep the proofs oral, just to save us all some time. 9 is less than r minus 3. Well, r is therefore greater than 9 plus 3. So we add 3 on both sides. Therefore, r is greater than 12. So, what happens when you have your right side be a number that's bigger than 12 minus 3? Oh, well, that's going to be a number bigger than 12 minus 3 is going to be bigger than 12 minus 3. What's 12 minus 3? Oh, that's 9. Okay, so right side bigger than left side. Well, that's exactly what it's supposed to be. So QED. So 5 is less than p minus 1. 5 plus 1 is less than p. P is greater than 6. Well, you would have right side is greater than 6 minus 1, which means right side is greater than 5. Right side is greater than left side. And that means we've shown that this is correct. Now, 3 is greater than a plus 3. A is less than 3 minus 3. So a is less than 0. Notice that unlike an equation where we can flip the sides and everything stays the same, when we change the sides in an inequality, we have to change the direction of the sign. Because we said, oh, 3 minus 3, so 0 is bigger than a. So if 0 is bigger than a, that means a has to be less than 0. Yes? Okay. And when we substitute in, that would give us right side is less than 0 plus 3. That means right side is less than 3. Oh, hey, right side is less than left side. Oh, what's been asked has been shown. 5 plus m is greater than or equal to negative 2. M is going to be greater than or equal to negative 2 minus 5. So negative 7. And when we put that back in, we get left side is greater than or equal to negative 7 plus 5. Okay, you simplify that and you get greater than or equal to negative 2. Oh, hey, left side is greater than or equal to right side. because right side equals negative 2. QED. All right, solve each inequality and check your solution. Then graph the solution on a number line. X plus 4 is less than 5. Well, x is going to be less than 5 minus 4, which is 1. So, x is less than 1. Yeah, labeling is a bit difficult in that case. So, negative 6 is greater than or equal to y minus 8. Well, if you add 8 to both sides, you get greater than or equal to y. On the other side, you get 2. So y is less than or equal to 2. That means you're looking at, if you go by the North American way, you just thicken up on the number line, and then you put your open or closed, in this case closed, circle at the end, and you put your arrow. As you can tell, I do not very much like this method. This method is, in my opinion, much better, especially if you have multiple inequalities and you need to find what range of values fits all these inequalities. Solving inequalities by multiplying or dividing. If you multiply or divide each side of an inequality by a positive number, the inequality remains true. However, okay, let's say, imagine we're comparing two values. So 0 is over here, and we got A and B. Now we know that B is going to be bigger than A, right? Okay then, what if we flip this over? Oh hey, this is negative A, and negative B is over here. Oh wow, now negative B is smaller than negative A. So if we had negative B and negative A written out like this, negative B is smaller than negative A, so negative A is bigger than negative B. Even though we can see that B has a bigger absolute value. When we multiply this positively, we stretch it positively. That's fine. You're still going to end up with the bigger value being stretched further, so it's still going to be greater. But if you flip it over and then stretch it or compress it, well, that's equivalent to multiplying by a negative number. And that flips the order of which one is bigger and which one is smaller. That's why the direction of the greater than or less than changes. So let's solve t over negative 2 is less than or equal to negative 3 and check our solution. So t is greater than or equal to negative 3 times negative 2. So t is greater than or equal to 6. So if we check our solution, we would end up with left side is, we start off with a value that's bigger than or equal to 6 divided by negative 2. So we're going to end up with a value that has an absolute value bigger than or equal to 3. But it's going to be negative. So left side has to be smaller than or equal to 6 over negative 2. which is smaller than or equal to negative 3. So left side is smaller than or equal to right side. Therefore, what's been asked has been shown. Now, graph the solution on a number line. We extend this a bit because we need to. And if we have a ruler available, we use it to keep this as to scale as possible. So 5, 6, t is greater than or equal to 6. Unfortunately, I can't exactly use a ruler on this thing, so that can't be helped. Okay, whether you have arrows or no arrows here depends on convention. Right. Some inequalities involve more than one operation. For example, you can have 4x minus 5 is less than 27. Then we check our solution. 4x minus 5 less than 27. That's going to be 4x less than 27 plus 5. So 4x is less than 32. X is less than a quarter of 32. Because we're dividing by a positive amount, okay, 4x is less than 32. Okay, that's fine, but 0 is over here. And x is then that's going to be less than a quarter of 32. 0 is over here, and this is where x is. Okay, that's still fine. You're just compressing. You're not flipping it over, which would happen if you're multiplying or dividing by a negative. So x is less than 8. Check your solution. Well, to check our solution, left side, because x is less than 8, left side is going to be less than 4 times 8 minus 5. So left side is less than 32 minus 5, less than 27. What do we get? Left side less than right side. QED. Of course, you may have to actually state that right side equals 27 at some point, depending, of course, on how much is required of you by convention. Still, stating it doesn't hurt. Solve each inequality and check your solution. Then graph the solution on a number line. We're going to be doing the checking by talking for the most part. Okay? Solve each inequality. 4x plus 7 is less than negative 1. Well, 4x is going to be less than negative 1 minus 7. So negative 8. X is less than, well, say we got from negative 8 to 0. So negative 8 is over here. And then 4x is less than that. Okay, now let's cut that into a quarter as much. So compress it over. Now it's x is less than, how much of it? A quarter of negative 8. So negative 2. Now let's say we want to check this by writing it out instead of by talking it out. We would find that left side is, what's the relationship between left side and 4 times negative 2 plus 7? X is less than negative 2. So the left side is equal to 4x plus 7, which is going to be less than 4 times negative 2 plus 7. And that means it's less than negative 8 plus 7. So less than negative 1. And thus left side is less than. Now we consider that right side is equal to -1. Left side is less than right side. Thus, what's been asked has been shown. Now let's graph the solution on a number line. So we see that x is less than -2, and that means we plot it like this. I'm drawing this in the no arrows version of the convention. Less than -2. Like you just kind of trail off here. Okay. 3x minus 11 is greater than or equal to -5. Well, you're going to end up with 3x greater than or equal to -5 plus 11. -5 plus 11 is going to end up with 6. X is greater than or equal to 2. Now, to check this, you got left side equals 3x minus 11. And because x is bigger than or equal to 2, this is going to be bigger than or equal to 3 times 2 minus 11. Which means left side is greater than or equal to 6 minus 11. So -5. Now right side is equal to -5. So left side greater than or equal to right side. Thus QED. Right, so the actual answer we got was x is greater than or equal to 2. So that's this. X is greater than or equal to 2. Yeah, if you're using the don't bother with arrows version of your inequalities, make sure that you go a little bit past the end of your number line, okay? Otherwise, it's going to be, hey, why did you stop like over here? But when the number line has already ended, this goes to infinity. If you're going past that, oh, you must be going to infinity. That's where the no arrows version even came from, really. Otherwise, just add an arrow. But even if you use arrows, it's still a good idea to overhang the end. Or at least come close. Solve each inequality. Check your solution. C plus 2 is greater than or equal to -2. Well, C is greater than or equal to -2 minus 2. So, yeah, greater than or equal to -4. And what we would get by checking is left side equals C plus 2 is greater than or equal to -4 plus 2. So left side is greater than or equal to -2. Right side equals -2. Therefore, left side is greater than or equal to right side. QED. This 13 is greater than or equal to 2y minus 3. Well, you got 2y, and you got a greater than or equal to sign here. So 13 plus 3. That's going to be 16. Y is going to be less than or equal to 8. Or you could say 8 is greater than or equal to y, but then you get y is less than or equal to 8. Okay, so you would have right side is equal to, I decided to show this step of it, 2y minus 3. And we know that y is less than or equal to 8, which means that this 2y minus 3 is going to be equal to or less than 2 times 8 minus 3. So, you're looking at right side is less than or equal to 16 minus 3. So it's less than or equal to 13. Now left side is equal to 13. And we have right side less than or equal to left side, which is what we see up here. Although you may want to write it in the way that corresponds to this. Given that they're labeled right side and left side already, though, that's kind of up to your discretion and whether your teacher requires it of you. As far as I'm concerned, this is when you can be a QED. What's been asked has been shown. We've proven this. We've checked it. Here, h over negative 5 minus 6 is less than negative 10. Okay, so h over negative 5 is less than negative 10 plus 6. So negative 10 plus 6 is going to give us negative 4. So h is greater than negative 5 times negative 4. You know what? I'm just gonna write that out for everybody's benefit, for you guys. And h is greater than 20. Okay, then this would mean that the left side is equal to h over negative 5 minus 6. Now, what do we know? We know that h is bigger than 20, but if we divide by negative 5, we're sure to get a number that's further from 0 in the negative direction than negative 4. That is why this thing, h is greater than 20, but h over negative 5 minus 6 is going to be less than 20 over negative 5 minus 6. The dividing by negative 5 bit turns this part into a negative 4, but h, which is bigger, divided by negative 5, is going to be more negative, i.e. less than negative 4. So left side is less than negative 4 minus 6. So it's less than negative 10. Right side is equal to negative 10. So left side is less than right side. And that's QED. What's been asked has been shown. Inequalities generally work just like equations. When you add or subtract, or when you multiply or divide both sides by a positive number, but when you multiply or divide the sides by a negative number, you have to change the direction of the inequality. This is because you can think of it like flipping over the number line. Remember that little sketch I gave you guys for 0 and then A and B, then you had negative A and negative B. Yeah, if you have, A is smaller than B, yeah, true. But if you multiply both sides by negative 1, what happens? You have negative A, it's suddenly bigger than negative B, because negative B is more negative now. And if this was negative A over 2 and negative B over 2, well, you can say that you flipped it over and then you scaled it back to half as much. But scaling it back, compressing it to half as much, you're still going to find half of negative A is closer to 0 than half of negative B. Because negative A was closer to 0 than negative B. You flip the inequality when you multiply or divide by a negative number. Other than that, and the fact that when you substitute in or left side or right side, you should probably show this step where you compare your substituted version to what your variable is referencing. And other than that, these work just like equations. So, that's it for this chapter. See you next chapter.